Hey everyone, welcome to another video. Before we get started, please like and subscribe and comment any suggestions you have for future videos. That'll help us out a lot so we can keep making content for you guys. So again, I'm joined with our mechanical engineer trying to improve his software skills.
Hi there.
So last time we went over classes, just a really basic introduction on the syntax and kind of how they work and the purpose behind them. So today we're going to talk about this data structure called a linked list. So we're going to use what we learned in classes to construct a linked list. So the general idea behind a linked list is it is a bunch of nodes that all point to each other in a singly linked list is what we'll talk about today. There's a thing called a doubly linked, but we won't worry about that. So what it does basically is we have a bunch of these nodes, and these nodes will have data associated with them. And then within that node class, we will point to the next node in the list. So some of the benefits of linked lists are if you have an array of elements, for example, these are kind of interchangeable and you use them under very specific situations for what you plan to be doing. If you want to add or remove elements from an array, it's very costly because you kind of have to pull out, say you have an array of size 10 and you want to remove something at index 4, then what you're really doing is you're pulling out 4 and then shifting the whole list left, everything that was to the right of it. And it becomes really costly to do just in terms of the time complexity, right? Now in Python, it might be pretty easy just because they have a lot of these built-in methods. But under the hood, all this work is being done that you don't necessarily see. But it's always good to keep in mind that even though Python has these nice methods, they are or can be very costly. So to start off, let's just define a node. So this will be a class. So let's do class node.
Define class node.
Oh, for classes, we can just say class, remember?
Oh.
And it's lowercase. And then there you go, just like that.
Okay.
So let's do, just put a colon there, and then we can define the constructor. Do you remember what that is, the function for that? It's the weird
init?
source. Yep. But it is a function, so make sure you say def. So this will take in, because it's a class, it'll take in self, and it will also take in data. So now the two things that are going to be in our each node is going to be self.data and self.next. So next is going to point to the next node in our linked list. So if you just want to assign self.data equal to data, and then we're going to assign self.next equal to none. We don't, if there's only one thing in our linked list, then we want to make sure that we have some way of telling when we're at the end of our linked list, right? And none is it is a capital N.
Okay. Yep.
Yeah. All right, cool. So now what we'll do is we'll make another class. This is our node. The nodes are all set. We'll make another class called linked list, and we'll make this just so we can call some functions. We're going to write a print linked list function, and it'll make it like a little bit easier, even abstract it even more for us, so we can just quickly call the print. So here, a linked list has this thing called a head, and what that is the first element in the list. So the head can move around. Say you remove the first element, you want to reassign head, right? So for this one, we need another constructor. And then this will actually take in nothing. And then we will, every method is going to take in self though. So self is, yeah. So if I say it takes in nothing, you still have to put self in there. So that way it knows it's referencing the instance of the class. And then here we can just set self.head equal to none. Because this will just be when we first make it, we don't want to add any nodes to it. And we can just set that equal to it and move on. And now what we'll do is we're going to print our list. So let's make another function called print list.
In this class?
Yep, because again, we're writing this so that way we can construct our linked list, and then we can just call like linked list.print list, and it should print our every element we have. So now this is where some logic comes in. So what we have to do is basically iterate through our linked list, and also make sure you put self as the every function you write is going to have parentheses. And if there are no parameters, then you just open close colon. But within a class, we need to make sure we put self in there.
Gotcha.
So what we're going to do is we have to iterate through our list, knowing that at every step, we are going to want to reassign some iterator to move to the next node. And all we're going to want to do is print the data, okay?
Mm-hmm.
So to do that, we can just have a temp. So we just call it temp. And then for the first pass, we want to set it to the head node, right? Because that's the first element in our list. So in our constructor, we basically, when we initialize our list, we can say at the bottom below, we'll just say that our head equals node, whatever we want, data.
Mm-hmm.
And then, so now by doing this, you basically say we have some temp, something to iterate through the list, and it's set to the first node in our linked list.
Mm-hmm.
So then to loop through, what loop do you think we're going to want to do? And what is the condition that we need to have in order to loop through a linked list cleanly?
So a loop, we need a for or a while loop, I believe. So while temp points to the next node, we want to do something, correct?
That's one way to do it. Instead, though, let's just make this really simple.
Mm-hmm.
So I said that none is basically our sort of flag to say when
To stop, yeah.
we're done.
Mm-hmm.
So a little trick you can do is you can just say while temp.
Parentheses?
You don't need the no. You can just say while temp. Yep. And so within this, so now what we want to do is we want to print our data. So we're going to print temp.data.
The point of temp here is that if temp equals none, then this doesn't execute, correct?
Exactly. Yep.
Okay. Sorry, so would we want to print something?
Well, yeah. So now let's think of what we're iterating through, right? We're iterating through another class, right?
Mm-hmm.
Or we're iterating through our linked list, but our linked list has objects in it. So to do that, you can just say, as if you were accessing these variables out like at the top level of the program, you can just say temp.data.
Yeah.
So now let's assume that it will happen when we code up the bottom part, but on line 10 there, you're basically saying that temp is self.head and self.head is going to be a node.
Mm-hmm.
So here we're saying whatever node is temp.data to give us whatever value we have, right?
Yeah.
And then make sure you put the parentheses around that for the print call.
Mm-hmm. Yeah, good call.
Old Python would let you do that, but not Python. So now we just printed the data. So what do we have to do next?
We have to set the next temp to the next node.
Right.
So I think we use the self.next. So I think we do temp equals temp.next.
There you go. All right, great. So this is that's gonna conclude the print. So now outside in the top level, let's just test this, and we'll make a linked list, and we'll make some nodes, and then we can link them all up and then print them out. So let's start off. You can just call this like LL for linked list, and we'll set that equal to a new linked list.
Like
you're just making an object of type linked list. Yep.
Okay.
And then remember, you need the parenthesis calls to do that. Okay, so now we have a linked list, and due to the constructor we just wrote, the only thing that this thing has is self.head equal none, right?
Yeah.
So what we can do now is we have to assign that head, right?
Mm-hmm.
We need to make it a node. So on line 16, we can start making some nodes here, and you can just say ll.head because we need to assign that now. And we can set that equal to a node, so capital N. We'll make another object, right? So node, and then let's just put the number 1 in there. So remember that node as a constructor takes in self and data. So now we have 1 as our data here.
Mm-hmm.
And then after this, why don't we just say, let's just say second, a second one.
Say what, second?
Yep, and we're going to set that equal to node with 2 as the data. All right. Just backspace the call there. So.
Yeah, the space. Yep.
And then let's just make a third one that is a node with 3. So now we have 3 nodes, and the first node is actually set into our linked list as node with data 1, right?
Mm-hmm.
So head is going to be a instance of a node with data equal 1, but self.next equals none. So now what we have to do is basically link all these up, right?
Mm-hmm.
We need to construct the linked list, and we could definitely write like a method within one of these classes to do this, but just to learn it, we can just type it up. So now what you're going to do is this is going to get a little fun. So we're going to say we want our head of our linked list, right? We want the next node to point to second. So how do you think we do that?
Are we doing it in our class here, linked list?
Yep, because we want to reassign the self.head. We want to make sure that whatever is set there, because we just assign on line 17, that's a node, right? ll.head.
Yep.
We want to set that node's next to second.
Okay, do we do it in the while loop?
Oh no, that's just to print it out. We're just constructing our linked list at the top level now.
Okay, so we're doing it here, correct?
We're not even going to be doing it in the linked list class. We're just doing this outside. It's just outside, the driver
okay.
code. Yeah.
Okay.
So, because ll.head doesn't exist anywhere else, right?
Yeah.
So for this, you can just do ll.head.next. So what we did there is we said, linked list is a class. We are referencing the head member, and we're setting, and we know that is a type node, and we know that nodes have a .next. And you're going to set that equal to second, which is also a node.
Okay.
And now we already know that that second has its thing, so we can just say second.next equals third. So by doing this, we just link together the 3 nodes and all of them, because we assigned it the first head node as part of our object LL. All of our nodes are now accessible within our linked list object that we instantiated. Right?
Yeah.
All right, cool. So now why don't we just test our print function, because we just linked all these up. So why don't you just say ll.print list?
I haven't. Print underscore list?
Yeah, it's what you defined it as. And then that doesn't take in anything, right? So let's just run this and we'll see what we get. There you go.
1, 2, 3.
So if you look, like I said, there's a lot of ways to do this, but on line 23, we are calling a method in our linked list class to print the list that we just constructed in the driver code, right? So that while temp thing there, that's going to be what you did to print the list there is going to be really key when you get asked any linked list questions, like iterating through lists and setting these temp pointers there. So on line 10, we have a temp equals something, like setting these iterators. That's really important for linked list questions. They can get a little bit confusing. If we had a whiteboard or something, it's really easy to conceptualize things, but sometimes coding it up can be a little hairy. But yeah, so for this one, we'll definitely come back to this data structure in the future. But what I wanted to show you is that we have a linked list class that is basically comprised of nodes. So we have 2 classes that are within each other here. So definitely a little bit confusing the first time you ever do this. And like I said, I would be surprised if you come across a bunch of lists in the real world. But yeah, so good job. You printed your first linked list and you constructed the first one. So they will definitely come back to haunt you. Don't worry about that.
Great.
All right, great.